Assalamualaikum everyone. My name is Syed Danial. I'm a student from National Defence University of Malaysia from the Department of Civil Engineering. So today I'm going to share with you guys about a topic in hydrology. So welcome everyone. Our first agenda today is infiltration and percolation process. And the second one is factors affecting infiltration rate. There are a lot of factors and we are going to go through briefly about all the factors. And the last one is soil moisture in the soil. So let's get started. Okay, the man in the picture is an American geologist named Robert E. Houghton. The infiltration term first used by Houghton in 1935 to describe the process of soaking water into soil. So let's understand the topic deeper. Infiltration is the process of water entering the soil through the soil surface, while percolation is the process of downward movements of water into the soil when water enters into soil. So, what is the relationship between these two terms? Okay, when percolation stops, infiltration also stops. But when infiltration stops, percolation is continued. So let's look at an example. So this is the visual of infiltration process. The precipitation is actually the rainfall in particular places. So when the water from the rainfall reached the ground, infiltration occurred because of the soil. The soil is permeable to the water, so the water can pass through the surface. When the water enters the surface, percolation will happen because of the gravity pull exerted on them. However, in some cases, not all the water was infiltrated. There are also water that run off to the nearest storage, such as river. So moving forward to the next agenda, which is the factor affecting infiltration rate. There are a few factors affecting infiltration rate, and today I'm going to share with you guys a few. So the first one is the vegetation cover. The vegetation will capture falling precipitation, keeping the water from being absorbed into the earth. This is because the branches, the leaf, and etc. of the vegetation will stop the water from hit the ground, and this will cause the water to take more time to reach the ground. Thus, the infiltration rate will become lower. So the next one is the moisture content. When soil moisture is high, infiltration rate is low. This is because when the soil moisture is high, there are enough water in the soil. Thus, it decreases the water flow in the soil. So when the soil moisture is low, infiltration rate is higher. Okay, the third one is the temperature. As we know, viscosity of water change with temperature. Increase in temperature cause reduction of water viscosity. So infiltration rate is higher when the temperature is high. So the next one is the slope of the land. The steeper the slope, which means the gradient, the less the infiltration at the seepage, such as hill. The infiltration rate at hill is lesser than the infiltration rate in a football field. The next one is the degree of saturation. The more saturated the loose earth material are, the less the infiltration. Number 6, the porosity. Porosity is the percentage of open space which is pores and crack in Earth's surface. The greater the porosity, the greater the infiltration. This is because when the greater the porosity are, that means there are a lot of holes. So the holes make the water able to flow. So when the higher the porosity, the higher the infiltration. The next one is the compaction. High intensity rainfall caused compaction in soil, thus less infiltration occurred. So the next one is the land use. Nowadays, there are a lot of construction on Earth. Thus, the construction is creating surfaces that are not longer permeable to water. Thus, infiltration rate is lower because the water cannot pass through the surface. As we can see in the picture, there is a parking lot. The parking lot surface is a cement, and water cannot pass through cement. Thus, the infiltration rate in this area is lower. And the last one is the presence of groundwater table. If groundwater table is present near the earth surface, the infiltration is less. So moving forward to the next agenda, which is the last agenda for today, which is the distribution of soil moisture. The highest part in the pictures is the water content. So the below of the water content is the saturated zone, which means the soil in this zone is the most saturated one. Moving deeper, below the saturated zone is the transmission zone, and moving further deeper is the wetting zone. So I think that's all from me. Thank you for staying with me until the end. I really hope that you learned something about infiltration and percolation process. Thank you and Assalamualaikum.